Alrighty. Um, this is the last calculus lesson of the semester. Not the last lesson of calculus, though. Um, so we're going to kind of extend Skill 24 a little bit and also kind of show the application problems of implicit differentiation. And this is titled Related Rates. So you may be wondering, when are we ever going to use implicit derivatives? So I'm going to kind of tell you a funny story here. And this is going to give motivation to our triangle problems. So we have the classic ladder against a wall problem that maybe you've seen in geometry. You use like trig or Pythagorean theorem to be able to solve it. And imagine that we have, some mischievous, greedy person who wants to just push the person that's on the ladder. And the ladder, starts moving down the wall. So when we actually start adding motion in there, we have rates of change. So we have rates of change in the height of the ladder. Um, we have rates of change in how far the ladder is from the wall when we do that. And this is where we're going actually with related rates. So what we're actually going to do our related rates problems today is we actually are going to base them off of our basic formulas in geometry. So for instance, if we have a triangle problem today, we're going to be basing these problems off of the famous a squared plus b squared equals c squared. So the implicit formula is 2a dA dt plus 2b dB dt equals to 2c dC dt. So these just kind of represent rate of change of the A, rate of change of the side B, and this would be like rate of change of side C. And we do give you most of the rates of change. And then A, B, and C, are just like, what you would see in a geometry Pythagorean theorem problem. Rectangles, we give you the area and the perimeter problems for these. So in geometry class, our perimeter is 2W plus 2L. So our implicit formula would be dP dt. This would be 2 dW dt plus 2 times dL dt. And this would be your perimeter change formula. And then the area of a rectangle formula, your famous length times width, is actually the product rule pretty much. So consistently, we use length times dW dt plus width times dL dt. So we just kind of cross it with the rate of change, when we're doing the implicit derivative. So like this would mean, change of length. And then the dW dt would be change of width. And our dependent variable in all of these situations is time. So note dependent variable is time. All right. Let's actually take a look at some problems now. But before we do that, I want to just kind of give a roadmap here and some steps that you should do. So just like if we had these problems in geometry and they were kind of word problems in geometry, I would have you draw a picture of a situation. So you want to make sure that you have the basic geometric shape. And you actually want to just start by writing the basic geometry formula and implicitly differentiating that geometry formula. And you want to have a good read of a problem. You want to write down all the variables that you know and the rates of change that you know, and also what you want to know. And then you just solve for what the question is asking by plugging in what you know to solve for what you want to know. So make sure that you are plugging in what you know. So we'll just add that. Okay. Let's do a triangle problem. All right, so we have a right triangle, and it's asking us what the rate of change is of the area. And on the general formula sheet, I forgot to put the area of a triangle here, but I will put as an area of the triangle. I'm just going to put that basic geometry formula. So area equals to 1/2 times base times height. And you may find it helpful to just kind of map out your product rule. Just to kind of motivate things. And when you kind of cross this and do the dA dt, you get the, so kind of remember like when you're doing the product rule, you match your u and your v prime. So I would have 1/2 b times dH dt plus 1/2, and I'm just going to do the h, put that in front, and then I'll put the dB dt. And it's asking us for the rate of change of the area. So we have a right triangle, and it has legs of 36 and 48. So I'm going to call this my H, and I'm going to call this my B. If you kind of like flipped it around, you would still be okay. And the short leg is decreasing. So what that means here is that we're looking at the short leg, so the height is shorter here. So we're going to say that dH dt equals to -8. And it says that the long leg is shrinking at 9 inches a second. And so what we would have here is I would do dB dt equals to -9. And it makes sense actually So like, dH dt, this tells us, so the H or the B, are measured in inches, and the T is measured in seconds. So we kind of have all the major data here. So I have the dH dt, the dB dt, the H, and the B. And then I'm just going to now plug them in. So I have 1/2 times my base, which is 48, times my dH dt. And then I have, after that, I'm just going to add the 1/2 times my H, which is 36, times a -9, which is my dB dt. And what I will do is just enter this in my calculator. I'm just going to kind of do it one step at a time. So this would be a -192 plus, I got 36 times a -9 times 0.5. So this would be a -162. And we combine those. I get -354 inches squared per second, because it's asking us for the change in area. All right, let's look at another example. Let's go to a rectangle. So a rectangle has a length of 1 inches and a width of 12. So what I'm going to do is I'm just going to draw this rectangle. So it's going to have a 1 by 12. So L equals 1, W equals 12. We could give one of my geometry students next period that problem and they would be able to do it. It tells us that the dL dt, the change of length, is increasing by 7, so it's a +7, and the width is growing at 8, so this would be dW dt. And the question is, what is the change of area going to be? So I'm just going to write dL dt and dW dt. So this would be 8, and this would be 7. So I'm going to start with the area formula. So I got length times width. Now, if you're kind of like playing along here and you want to do like a little product rule, you can. This would be dL dt. The v would be w, and the v prime would be dw dt. Or you could just kind of use the formula that we defined a little bit earlier. But our implicit formula would be L times dW dt plus W dL dt. Now, it's asking us, what is the rate of change of area? This is saying, what is dA dt? How much is the area changing over time? That's what the question is asking. So I'm going to substitute in what I know and what I don't know. So I don't know dA dt. But what I do know is my length, which is 1. I know dW dt is 8. I know that W is 12. And I know that dL dt is 7. So I'm going to go to my calculator. So I'm going to do 12 times 7. So that's 84 plus 8. And we are increasing at a rate of inches squared per second because we are increasing in area. So the total area is increasing at that rate. So obviously, if your length and width are growing, consequently, your box is getting bigger, and that's why we have that positive value for dA dt. Okay, let's go to another rectangular example. Oh no. Oh well. Let's just go on to some delta math and we'll just kind of see what happens here. I'm just going to pause. Oh, okay. So I was actually able to get the other two types of problems that I wanted to do on the PowerPoint. So now let's actually do the perimeter of a rectangle as well. So I like to kind of read through the problem. Obviously, you could give a run-of-the-mill geometry student, they could read this as length. They can read this as width. When it says decreasing by 6 inches per second, that is the length. So I would say that dL dt is -6. Be sure that you are putting the signs. And then growing at 3 is the width. So dW dt is a positive 3. And we'll just kind of put the units in at the end. All right, the perimeter formula that you should have remembered from geometry class is 2L plus 2W. So if we are actually doing the implicit derivative of this, it would be 2 times dL dt plus 2 times dW dt. And then I just substitute in what I know. So the dL dt is -6, and the dW dt is +3. And here, I mean, we kind of have two conflicting forces. So the length is decreasing, but the width is growing. Let's see if this increases or decreases over time. So this would be slightly decreasing at -6 inches squared per second. All right, the last problem that I want to do is a Pythagorean theorem problem. That is a related rates problem. So I want to make sure we got that under the belt. I'd say these are some of my favorites, just because I like trig a lot. So let's see. We have in this problem, it says that we have a right triangle with legs of 24 inches. And 32 inches. And it does not give us the hypotenuse, but we can find what that hypotenuse is. So I'm going to do 24 squared plus 32 squared equals to c squared. This is just our basic Pythagorean theorem problem. So we have to find the hypotenuse. And I'm just going to kind of use my calculator here and figure out what the hypotenuse is. So it's going to be a 576. 32 times 32. It's going to be 1,024. equals to c squared. So c squared is equal to 1600. So c, if we take the square root of that, is 40. So I like to, kind of just use that Pythagorean theorem to get where we need to go. All right. We have that the short leg, which we called A, is increasing by 2. So the short leg is our A. So our dA dt is plus 2. And our long leg is growing at 7. So dB dt would be a plus 7. And the question is, what is the rate of the change of the hypotenuse? So dc dt equals to question mark. So I like to start with a basic geometry formula. So I have a squared plus b squared equals c squared. If you differentiate, you get 2a dA dt plus 2b dB dt dB dt equals to 2c dc dt. And what I would do here, I wouldn't solve for dc dt, but I would just plug in what I know and what I don't know. So what I would do, and I'm just going to kind of rewrite so that we can kind of see the solution here. dB dt equals to 2c dc dt. So what I would do here is I would put into A. So I got 2 times 24. My dA dt is going to be 2. And then my B is given to be 32. And my dB dt is plus 7. And then my C is 40. And I do not know what dc dt is, but I can easily solve for that. So at this point, actually, it is just solving for dc dt. So I'm just going to use my calculator. So I got a 96. And a 448 equals to 80 dc dt. And I got for this that I have 96 plus 448 gets me to 544 equals to 80 dc dt. And I'm just going to divide by 80. And I get that dc dt equals to 6.8. And it's in inches squared per second. So this is your full-on Pythagorean theorem problem. So we did want you to find the hypotenuse of the triangle. That you could do with some basic geometry. And then all what you have left that you really need is to find that rate of change of the hypotenuse. So on delta today, we will assign you implicit derivatives from a point, and then the related rates of the rectangle and the triangle problems. And that will be your IP for next class. So thank you very much for checking in, and we will talk about how to prepare for the final exam next week.